The word trigonometry means measuring triangles. Trigonometry, triangle measurement. Okay? So we're going to be in particular interested in triangles that have a right angle in them. The word trigonometry, measuring triangles, really encompasses a whole lot of things, including similar triangles, including Pythagoras' theorem, and then a whole lot of extensions on top of what we're doing here. But for the moment, we're just going to be looking at trigonometry in terms of three particular functions, which you've probably heard of: sine, cos and tan. They're actually sine, cosine, tangent. That's why I say sine and not sin. And here's where they come from. Suppose I get a right angle triangle, okay, with a particular angle. If I measure this length and this length, I will get a number. We'll call it a ratio of this side to this side. For this triangle, the height over the width. I'm going to use different terms in a minute. But if I were to draw a different triangle, this one, so this small one here, that has a right angle in it, it also has the same angle here. And of course, if it has the same angle here and a right angle here, then these angles must also be the same. Because to work this out, I just go 180, the number of degrees in a triangle, minus those two. So this angle and this angle must be the same. Which means these two triangles are what we call similar. And that means if I get this length divided by this length, the whole lot, it's going to be the same as this length divided by that length, because they're similar triangles. In fact, I can draw some more. Here's another one. That's a different triangle, but it has the same angles as we started with. So this small triangle here also has the same ratio of height to width. In fact, any triangle I draw here with the same angle here and a right angle here is going to have the same value for the height divided by the width. And so what we do is we invent a function called, in this case, tan, that tells me the value of height divided by width, as long as I know this angle. Okay, so it depends fundamentally on what that angle is. But if I have that angle, it tells me that ratio, which means if you tell me the width of your triangle, and I know this angle, then I can tell you the height, because I know what the height divided by the width is supposed to be. And that's the basis of trigonometry. Okay? Trigonometry, put that down. Trigonometry is just a clever way of working out lengths and angles in right angle triangles. In fact, as an extension, you can actually use it when there isn't a right angle and there are adjustments you have to make. But we're not going there today. Trigonometry, to the extent we're looking at here at the moment, is just, if you have a right angle, you're going to use one of these other angles to calculate lengths, or you're going to use a couple of lengths to calculate angles. So, there are three ways we can look at it, because there are three different ways of pairing off sides on this triangle. Before we get there, we need some names for these sides. So, to start with, this is my right angle. The side opposite that is the longest side of the triangle, and that is called the hypotenuse. I'm not going to write the whole word, maybe I will down here. Okay, the hypotenuse. That is the longest side of the triangle. It's also the one that's opposite the right angle. So far, so good. If I have one other angle there that I'm interested in, let's say this one, I'm going to give it a name. The name I'm going to give it is a theta. Now, the reason I use theta, pardon me, theta is the Greek letter th, the Greek letter theta, okay? We use Greek letters for angles just because the Greeks were some of the first mathematicians to play around a lot with angles. So we tend to use Greek letters for angles. Anyway, so if this is my angle theta, well, one side of my triangle is already named. It's the hypotenuse. But actually, I can give names to these other two sides. This side is opposite my angle. It's the opposite angle. Notice I don't just use a capital O like some textbooks do, because if you put a capital O here, later on you're going to get confused and think it's a zero and not really work out what's going on because you're confused by the zero. It's not a zero, it's opposite. That's why I always use 3 letters to label my sides. Okay, this one is opposite the right angle, it's the hypotenuse. This one is opposite the angle I care about, opposite. This side is next to the angle I care about. And if we're trying to be fancy, just because we are, we're going to call that adjacent instead of next to. Adjacent is just a fancy word for right up next to it, right up against it. So this side is adjacent to my angle, and this side is opposite my angle. Okay, how can I pair those off? I can have the opposite and the hypotenuse together. I can have the adjacent and the hypotenuse together. Or I can have the opposite and the adjacent together. 3 different ways to pair off my sides, which gives me 3 different trigonometric functions. Sine, cosine, tangent. That's what they really are, sine, cosine, tangent. I do tend sometimes to say cos and tan, but I always say sine, not sin, because it's so much easier to just call it a real thing. It's only 1 syllable anyway. So sine, cosine, tangent. And they're just names for a function. Give it the angle, and it will tell you the ratio of the opposite to the hypotenuse. In the case of what I started with, okay, this triangle here, this set of triangles here really, I was looking at this angle, so this was my opposite, my height was opposite, and this was my adjacent right next to it, because this side, of course, was the hypotenuse. Maybe I'll write those in. Hypotenuse, opposite, adjacent. Okay? So in this case, if I was looking at opposite on adjacent, I was looking at the tangent ratio. Okay? Tan, opposite on adjacent. You do have to remember these. You have to come up with some way that you can remember sine of theta is opposite on hypotenuse, cosine of theta is adjacent on hypotenuse, and tangent of theta is opposite on adjacent. Many people just remember SOHCAHTOA, which means sine is opposite on hypotenuse, cos is adjacent on hypotenuse, tan is opposite on adjacent. SOHCAHTOA. Traditionally, there's been a little rhyme that everyone learns for trigonometry. Some old hags can't always hide their old age. That's traditional. But of course, there are many other alternatives. Let me see. Some old horse caught another horse taking oats away. Saviour of humanity, Christ abased himself to our advantage. You pick whatever you like. You can just remember SOHCAHTOA. You can remember some old hags. That's traditional. You can make your own up. It doesn't matter. But you need some way to remember which pair of sides and the order they go in is associated with which of my 3 functions. Notice also the way they're written. There's a theta here. Sine theta, cos theta, tan theta. there is always an angle associated with it. You can't just write sine is opposite on hypotenuse, because sine needs an angle. You've got to have an angle in there. Sine theta is opposite on hypotenuse, and so on. Let's try it.